Here I'm going to do another demonstration of Faraday's law. What I have here is a fine coil of wire, and it's wrapped around an iron shaft, an iron core. And when we send current through this coil, a very strong magnetic field will be created, which, because the iron core is inside, it gets magnetized, and this increases the field strength. They've made the iron core stick way out of the coil here. The whole piece of iron, though, will get magnetized by the field of the coil. So we're going to have a nice strong magnetic field coming up here on this shaft. Okay, what I've got here is an aluminum ring. Remember, aluminum is not ferromagnetic. Okay, so magnets are not attracted to aluminum or anything like that. So I'm going to place the aluminum ring over my coil here. When I hit this button, current will be able to flow through the coil, creating a magnetic field. Okay, so we're going to go from having no magnetic field to having a very strong field in this coil. Okay, that means we're going to have a changing magnetic field. A changing magnetic field through a metal loop will create current according to Faraday's law. So current will start to flow in this metal ring. That current will then create a magnetic field, and as you'll see, that magnetic field's repelled by the magnetic field of the coil, and this metal ring will shoot up into the air. It's going to hit the ceiling and fall back down. So watch what happens when I hit the button. Actually, let's turn it on first. That's always useful. Now I'll hit the button to turn the current on. So it's shot up into the air. Let me do it again. Okay, so I can shoot this ring probably about 20 to 30 feet across the room if I wanted to. All again because of Faraday's law. If I could hold this thing down and keep it from jumping, all that current flowing through the ring would make the ring very hot. The problem with this is the coil is going to get really hot if I leave the current on all the time, and it's a real fine coil, so it'll melt. So it doesn't allow you to keep the current on for very long. I have to wait a little bit, then I can hit it again, hit it again, hit it again. Now, if you'll have to believe me, this ring is actually quite warm, indicating a large current has been flowing. If you do that enough, you can actually melt the metal. Okay, here I've got a plastic ring I made out of an old bottle, plastic bottle. Since it's an insulator, what do you think is going to happen when I turn the current on? Well, let's see. Nothing. So even though there's a changing magnetic field passing through my loop, because it's an insulator, current cannot flow through the loop. So no magnetic field is created, so no repulsion. So the piece of plastic ring here, it does not jump through the air, unlike the metal ring, which works just fine. So anything that's a good conductor would work. So here I've got another aluminum ring just like the first one. I'll put it on, and oh, hey, now nothing's happening. So why is this? Why does this ring not shoot up when its neighbor, its partner, works just fine? The two rings are the same size. They're both made of solid metal. What's the difference? Well, this second ring has a split in it. So it's actually not a complete ring. So that means current cannot flow all the way around the ring, so you can't get a magnetic field, so there's no repulsion. So the split ring does not fly